All right, welcome. This is going to be the video on 6.5, and so let's go through this. And we're going to be talking tonight about something that gives us a chance to use proportions, and that is specifically talking about scales and scale drawings. All right, so let's get into this. First of all, let's talk about what the definition of a scale is. And here is the definition right here. So a scale is nothing more than the ratio of the length in a drawing or in a model. I don't know why that's a T there. It should be model. Okay. So it's a ratio of the length in a drawing or a model to the actual length in real life. Okay. So let's take a quick look at an example here. So suppose we have a map. Maps have keys or legends, usually down in the corners. And suppose you have a map that tells you that 1 inch is equal to 12 miles. Well, that is an example of a scale. And I can use that scale in a couple different ways. So, for instance, take the scale 1 inch is to 12 miles, as 3.5 inches is to x in terms of real distance. Okay, so if I were to measure 2 points on a map and they're 3.5 inches apart, how far are those two places away in real life if you were driving from one to another? Okay, or let's do the other way around. Suppose you know that two objects are 60 miles apart. Let's say Louisville and Versailles maybe. Okay, let's say it's 60 miles between the two. How far apart should they be on the map? So let's just kind of reverse that same problem. Now both of these problems are going to use proportions. So what we're going to do is we're going to cross multiply on them. Okay, that's one way to do it. Or we've talked about the different ways to do proportions now. On the bottom one, you might notice that 12 goes into 60 exactly 5 times. So we could also do the arrow method, where 12 goes into 60 5 times, so multiply the top by 5. So y here ought to come out to be 5 inches. And sure enough, if I cross multiply this one, let's go back to the pink. If I cross multiply this bottom one, I'm going to get 12 times y is equal to 1 times 60. And if I divide both sides by 12, sure enough, this cancels out. I get y equals 60 over 12, which does in fact equal 5 inches. Okay. The top problem, by the way, let's back up for a second. The top problem, if I cross multiply and divide, again we'll do this in pink. 1 times x is equal to 12 times 3.5, and 12 times 3.5 equals 42. And so this would be 42 miles. So something that's 3.5 inches from another thing on the map is actually 42 miles apart. The two objects are 42 miles apart in real life.
Friday.
So that's an example of how to use these rates. And actually it kind of makes sense that we can go in both directions. All right, let's move on. Suppose you had a model, like a model train or a model car, or you're making maybe a model of a ship or a plane. And let's say that the scale of the model is 1 to 30. Notice they don't say any units here. That would mean that 1 inch in the model is the same as 30 inches in real life, or 1 foot in the model would correspond to 30 feet in real life. So the question I've got up here is how long would a model be of a 12-foot car? So let's take a 12-foot car in real life and let's go backwards and figure out what the model length will be. So let's start with the rate. So the rate is 1 to 30, so we're going to set it as a proportion 1 to 30. All right, now the 12 is the big thing, the real thing. Okay, so it goes on the bottom, and we're going to put x on the top. Now I can cross multiply and divide this proportion, okay, and I could get the answer in feet. Or I could realize, wait a second, if I'm making a little model, it might make more sense to measure it in inches. So I could convert the 12 feet into inches. Let's go ahead and do that, because I think that's going to give us a better answer on this one. So 12 feet is the same as 144 inches. Okay, so now, that's not there anymore. We've got this instead. So we have 1 over 30 equals x over 144 inches. Now when I cross multiply, I get 30 times x is equal to... All right, so sorry about the ring. I've got a couple of friends from pre-algebra that came down to join me. So let's finish up this problem. I'll introduce you in a second. So the ratio was 1 to 30. So we were in the middle of cross multiplying here, guys. So, oh, look, I've got a friend from Course 1 too. Matthew's here, and Hampton's here, and Quinque's here. All right, we call him Quinque because that means 5. But because that's how he acts, when in reality it's Quinn Clay. Yes. All right, so let's go ahead and finish the cross multiplication I was in the middle of. So 30 times x is 30x, and 1 times 144 is 144. And what do I do now to solve this equation? What do I do to both sides?
You divide by 30.
Okay, good. Divide both sides by 30. Okay, on the left, we're going to get a nice little fruit ninja, and we're just going to get x. I'm going to go ahead and put it over here since I'm out of room. And now, if I'm doing this by hand, sorry, that looks like a 6, but it's a 0. These are both even, right? So I could take out a 2. This would be 72 over 15. Okay, and 72 and 15 are both divisible by 3. So if I take that out, the top will become 24, and the bottom will become 5. And 24 over 5, 5 goes into 24 4 times, with the remainder of 4. So we get 4 4/5 of an inch. If you did it on a calculator, you would have got 4.8 inches. Now, that should make sense, right? So we're talking about a model. Since we're doing a scale of 1 to 30, the model's going to be right about 5 inches long. Okay? So that's how we use proportions to do a scale problem. Okay? Make sense, guys? Okay, I know you're kind of jumping in the middle of the lesson here. But all right, let's take a look at another one. All right. Blueprints are another good example where we use scales. And so let's say we had a blueprint, and down in the corner it says that 1 inch is the same as 10 feet. And it would probably say it like this with a colon, although it might go ahead and have an equals there. So here's 2 different problems. Again, we can go 2 different directions here.
I gotta get your sister.
Sorry, we just lost Hampton. All right, so let's look at these 2 problems. So how long would a model be if I had an actual building that was 150 feet long? Okay, so in other words, what would the drawing, how long would that be on the blueprints? And, all right, let's do another question where we have a room in the blueprints that's 3.75 inches long or 3 3/4 inches long. On the drawing, how long would it be in real life? Okay, so for both of these, we're going to set up a proportion. We're going to start with the ratio they gave us. So they gave us 1 inch is to 10 feet. Now notice I actually put the units in. So that's how I can keep track of where the inches and feet go. So it's pretty obvious where I'm going to put the 170 now. Where do you think, Matthew? This is your lesson for tonight. So does the feet go on the top or the bottom?
Bottom. Yeah.
So we're going to put the 170 down here, and we're going to look for x. Now hold on a second. You can probably do this one without cross multiplying. What do I do to 10 to turn it into 170?
Times it by 17.
Good. So multiply the top by 17. And so the question is going to be how many inches would the drawing be? And the answer would be, it'd be 17 inches. Okay, in the perpetual revolving door of the people helping out, JP just came in. So JP and Quinn and Matthew are now helping with this. So we're doing scale drawings here, JP, and you'll see that on the video when you watch it tonight. Boy, lots of interruptions tonight. Thank you, Matthew, for closing the door. All right, so we're going to solve this ratio problem here. And so we're using a ratio on a blueprint of 1 inch is the same as 10 feet. So once again, let's go ahead and set that ratio up. 1 inch is to 10 feet. And this time, we're going to do a drawing, a blueprint, that is 3.75 inches long. So where do you think I should put that, guys? Top or bottom? Take a look at the ratio. You've got inches
bottom.
over feet.
No.
The inches?
Inches
yeah,
goes where?
Top.
On the top, right. So 3.75. Notice inches. So this is the scale inches, and this is my actual drawing, 3.75. And I'm looking for how long the room is actually going to be. So I can cross multiply this one. Since we did the first one with arrows, let's go ahead and do this one by cross multiply. So cross multiply, you get 1 times x. That's easy. That's x, right? Equals 10 times 3.75. Well, that's easy too, because what do you do when you multiply by 10? Just take the decimal and
Cut it.
move it to the
Right.
how many places?
1.
Right. So you get 37.5 inches. I'm sorry. Oops. My mistake. And we were changing into feet, so this should be feet. All right? So that's a pretty long room. Okay? And that's how this works. Okay, so that's an example of using scale. And so one more time, especially for the guys that came in a little bit later, and this guys, I guess that's in you this time, JP, but although you guys weren't here at the beginning. The scale, the definition of a scale, all it is it's a ratio of the size of something in a drawing or a model compared to its actual size. Okay, and sometimes the units are going to be the same, and sometimes the units are going to be different. All right, so just to wrap things up, that's it from the book. I haven't taken a picture of the book in a while, so this was Course 1, and on behalf of JP and Quinn and Matthew, we're signing off, and hope you enjoyed the video. Thanks for watching.
Bye.